Hello and welcome to another exam paper walkthrough. Today we're doing the Edexcel past paper series and we're looking at November 2020 and we're doing paper 2H, so that's the calculator paper. Attached to the description to this video you'll find a link to a Google Drive where you can download a copy of the paper. I would strongly recommend you've either already done the paper or you do it alongside the video just to get the most out of it. I also like to have some music on in the background and I would recommend that. And if you find this video useful, please do subscribe if you like. Okay, so question one. Write 84 as a product of its prime factors. On a calculator paper, on a calculator this is quite straightforward. If you press 84 and then press equals, that puts it into your calculator's kind of answer system. If you then press shift and then this button here, the time button, it's got fact in amber writing. That gives it you the power of its prime factors. So that's 2 squared times by 3 times by 7. You could break it down with a factor tree, but I always find that the most straightforward way. And again, I always take a shortcut on a calculator paper, find the lowest common multiple, or LCM, of 60 and 84. If I type this in as a fraction and see what it simplifies it down by. So 60 over 84. So it simplifies it down to 5/7. So what it's actually done is it's cancelled by the highest common factor, so it's cancelled by 12. And then if you take the numerator and multiply it by either numerator and multiply it by the opposing denominator, it gives you the lowest common multiple. So in this case, 60 times 7 or 84 times 5. Both will give you the same value. 60 times by 7 gives you 420, and then likewise, 84 times by 5 will also give you 420. So the lowest common multiple is 420. We can break it down with a factor tree, enter the factors into a Venn diagram and do it that way. But on a calculator paper, that's all I would do. Okay, question 2. Here we go with another Venn diagram. Complete the Venn diagram for this information. And then it says a number is chosen at random from the universal set, and that's that squiggly symbol. Find the probability that the number is in A and B, so in the intersection. So if I kind of run down these, as I'm using the digits 1 to 10, 1 is not even or a factor of 10, so it would go there. 2 is even and a factor of 10. 3 is neither. 4 is even but not a factor of 10. 5 is a factor of 10 but not even. 6 is even but not a factor of 10. 7 is neither. 8 is even. 9 is neither, and then 10 is in the intersection. So find the probability that the number is in the intersection. We have only got, and I've misplaced one of my digits. 1 is actually a factor of 10. So a number is chosen at random from the universal set. Find the probability that the number is in the intersection. So we've only got 2 digits there, so it would be 2 out of 10 or 1 out of 5. So I shouldn't really put both answers on the same line. So we're looking at 2 out of 10, which is 1 out of 5. And question 3. For question 3, we are looking. Carlo puts tins into small boxes and large boxes. He puts 6 tins into each small box, 20 tins into each large box. Carlo puts a total of 3,000 tins into boxes so that the number of tins in small boxes to the number of tins in large boxes is 2 to 3. Carlo says 30% of the boxes are filled with tins are larger boxes. I'm going to ignore that statement till right at the end. So we've got small to large in a ratio of 2 to 3. That's the actual number. We're splitting, in effect, 3,000 tins into that ratio. So we've got 5 parts to each ratio. So 3,000 divided by 5 gives us each part being 600. So let's clear up what I've written there. Divided by 5 equals 600. So each part is going to be worth 600. So we've got 12,000 in small tins and we've got 18,000 in large tins. So that's actually the number of tins. If we now look at the number of boxes, so if small boxes are 6 tins, so if I divide that by 6, that's going to give me 200. And if I divide that by 20, that's going to give me 90. So there are actually 20 boxes of large tins and 90 boxes of small tins. So now I'll come down to, Carlos says that 30% of the boxes filled with tins are large boxes. So I'm after 20%, 30% of the boxes. So I need to do 90 divided by the number of boxes, which is 290. Let's clear that digit up. 290 times by 100. That will give me the percentage of large. So 90 divided by 290 times by 100 gives me, as a decimal, 31.0344 . Show I haven't rounded it. Carlos says that 30% less than 30%. No. 31% over 31% are large. So that's only really the final stage. So what I've done there is I've worked out the number of small tins and the number of large tins. Then I've worked out how many boxes that means. Then I've used that to create the percentage. Okay, question 4. Complete the table of values for 5 minus x cubed. Again, on a calculator paper, I would take a lot of the grunt work out of this. So I would use the table function on my calculator, which is the third mode. And I'm going to type this in as a function of x. So I'm going to say it's 5 minus alpha x cubed. So that's my cube button. I'll then get, when I press equals, I'll get the option of putting in a second function, but I don't need the second function. I want my values to start at minus 2. I want them to go up to 2. And I want them to go in steps of 1. Which it's already set up for, and then that does the table for me. So it says when x is minus 2, y would be 13. When x is minus 1, y would be 6, which we've already got. 0, 5, and then 1, 4, and then finally use my replay button to move down through my table. I've gone too far. I get 2 minus 3. On the grid below, draw the graph. So I'm just going to plot those coordinates. Minus 5, 13 would be there. Minus 1, 6 would be there. 0, 5 would be there. 1, 4 would be there. And then 2 minus 3 would be there. Then I need to join it with a smooth curve. I tend to keep my wrist on the inside to make a smooth curve. I can use my can do a much smoother curve using, I think it's this function here, which hasn't hit. Let's try that one more time. Your job is to join that up with as smooth a curve as you can. I tend to always keep my wrist on the inside of a curve to get it as smooth as I can. So if I just join up these points with this line there, this will do an automatic smooth curve for me. So double click to finish. So that's my very smooth curve. If you're doing it freehand, keep your wrist on the inside of the curve that you're drawing, just to make it slightly easier for you. Okay, question 5. Work out the value of x, giving your answer correct to 1 decimal place. So we've got a question involving a right angle triangle, and we're given 2 of the sides and an angle. So that automatically tells me I'm using trig. My method for trig is fairly standard. I label the 2 sides that I'm working with. So this is, if this is the angle, that means that this is the opposite and this is the hypotenuse, which tells me I'm using the sine ratio. So SOH. To rearrange that to find O, O would be equal to S times H. So O is equal to S times by H. So X is going to be equal to the sine of 34. times by 178. And then that's the point I go to my calculator, put it back into calc mode. So sine of the angle, and then make sure we close the bracket, times by 178, gives us 99.5363. Anything that asks me to round, I always go further than needed, then I round, so 99.5. Okay, column vector questions. So 2 lots of A, so I'm just going to rewrite this, 2 lots of 3/4 minus 3 lots of 5/-2. And then it's kind of that straightforward. So 2 lots of this would be 6/8. And then if I keep it as a minus for now, 3 lots of 5 is 15. 3 lots of minus 2 is minus 6. And then 5 minus 15 gives you minus 9. And then 8 minus 6 becomes 8 plus 6, so 14. Okay, question 7. So the diagram shows a right angle triangle and a quarter of a circle. The right angle triangle ABC has an angle 90 degrees. The quarter circle has center C and radius CB. Work out the area of the quarter circle, given your answer correct to 3 significant figures. So it's not particularly nicely written. If I call this length here R for now, we need to use a right angle triangle involving 3 sides is going to be Pythag, and we're trying to work out the shortest side, so R squared is going to be equal to 9 squared minus 6 squared. And then I'm not going to go to my calculator just yet. I'm going to go a bit fancier. Well, not fancier, but the area of any circle is pi r squared, but we want a quarter of it for the area of the circle. So in effect, I'm just going to type it in like this on my calculator. 9 squared minus 6 squared over 4. And I'm just going to use my calculator once there. So type it in as a fraction, shift pi, and then I'm going to type in 9 squared minus 6 squared. The advantage of doing it that way is we only use the calculator once, and we also don't involve any square roots because we're substituting in r squared rather than square rooting and then squaring the value. So that gives us 45, the exact value 45 over 4 pi. But then as the decimal, that's going to be 35.34291. So to 3 significant figures, that's going to be 35.3. Okay, question 8. Tarek buys a laptop. He gets 5% off the normal price. Tarek pays £551 for the laptop. Work out the normal price of the laptop. Well, the normal price times by 1.05, that's the 5%. Sorry, I've done that the wrong way around. Times by the 5% discount would be a multiplier of 0.95. That gives you the value that you're given, 551. So the normal price of the laptop is going to be 551 divided by 0.95. 551 divided by 0.95 gives us 580. No rounding needed there, £580. Joan invests £6,000 in a savings account. The savings account pays compound interest at a rate of 2.4% for the first year, 1.7% for each extra year. Work at the value of John's investment at the end of 3 years. So we want to take the initial amount, we want to times it by this multiplier, so I'd call this 1.024 times by this multiplier, which would be 1.017, but we are applying that for 2 years, so that would be squared. So times by 1.024 for the first year, and then 1.017 squared for the second and third year. And don't need to break it down as a sum, we can do it just as a single type in a calculator, provided we type everything right. 1.017 squared, so that gives you £6,354.671616 ... So I would give it in pounds and pence, so I would go 6354.67. Okay, question 9. Aisha records the height in centimeters of some girls. She uses the results to work out the information in this table: least, lowest, inter, median, range. Aisha drew a box plot for the information in the table. The box plot is not fully correct. To write down two things that she's done wrong. So let's look. Least height 142. 142, I would agree with that. Lower quartile 154. So I would agree with that as well. Interquartile range of 17. So that's the difference between, so if I say lower quartile was 154, and if we've got an interquartile range of that, then my upper quartile should be at 171, and I don't think it is. So first mistake, upper quartile is not in the wrong place. Yeah, so upper, let's try and at least look like I can write. Upper quartile should be at 171, not 172. Also going to circle it in the diagram. Median 162, they've drawn it at 161, so median is in the wrong place. Median should be at 162, not 161. And then have we got any others? I think those are the two acceptable ones. We could have other versions of that though. Range of 40, let's just double check that. The range does work. So instead of saying that the upper quartile should be at 172, not 171, not 172, you could have said the interquartile range is 16, not 17. That's the same version, but it still looks slightly different. Okay, question 10 then, simplify. Well, anything to the power 0 will always be 1, so there's no real need to simplify anything there. Simplify this one. Well, as the numerator and the denominator are fully factorized, we can take out x minus 4 as a common factor and say that that's just going to be 8 over x minus 4. And then finally simplify. A lot of students struggle with this. They're absolutely fine with the n part and the w part. The n part would be 4 times 3, so it would be n to the 12. The w part would be multiply the powers, so it would be w to the 6. But the common misconception that I spot all the time is we don't do 3 to the power 3. So 3 to the power 3 would be 27. Okay, question 11. Jake is in a restaurant. There are 5 starters and 8 main courses and some desserts on the menu. Jake's going to choose 1 starter, 1 main and 1 dessert. He says there are 240 ways he can choose his starter, his main course and his dessert. Could Jake be correct? You must show your answer. So for this, in effect, if we've got 8 starters and 8 main courses, that alone would create 40 combinations. And that number of combinations times by, so in effect, 40 times by, let's call it n for now, can that be equal to 240? So for example, if there was only one dessert, there would be 40. If there were two desserts, there would be a total of 80 combinations, and so on. So if we do 240 divided by 40, that's going to give us 6. So could J8 be correct? Yes, if there are 6 desserts. Yes, if there are 6 desserts. Okay then, question E12. This graph gives information about the volume V litres of petrol in a tank of Jim's car after he has travelled the distance of d kilometres. So we've got volume on our y-axis, distance on our x-axis. Find the gradient of the graph. So the gradient, I like to pick either nice points or as big a triangle as possible. So I'm going to actually try and look at a bigger triangle as possible. So if I look at this triangle here, my y value has gone from what looks like 27 down to 0, so it's gone by minus 27, and my x has gone from 0 to 300, so it's gone 300. So the gradient of that graph is going to be equal to the change in y divided by the change in x. So I'm looking at, so if I type it in just like that, minus 27 over 300, too many zeros, over 300, minus 900, which as a decimal is going to be minus 0.09. So minus 0.09. Interpret what the graph represents. So the graph represents the rate of volume in the tank decreases proportionally with the distance. Sorry, what does the gradient represent? So the gradient represents the amount of petrol, the volume of petrol. Volume of petrol decreasing each kilometre travelled. So the gradient represents the volume of petrol decreasing each kilometre travelled. Yeah, that would be fine. Okay, on to, let's move that back. Question 13 then. Here is a triangle. Work out the length of AB correct to one decimal place. So we want to work out this length here. I'm going to call it X for now. So we're going to be using the sine rule. We've got a non-right angle triangle, and we've got a pattern involving 2 sides and 2 angles, which tells us we're going to be using the sine rule. I'm trying to find a length, so I'm going to say that X over sine of the opposite angle, so sine 34, is going to be equal to, and I am going to write it like this for now, divided by sine of the opposite angle, but we haven't got that yet, so I'll call that y for now. And then I'm going to say y is going to be equal to 180 minus 26 plus 34. So that adds up to 60, so 120 I believe. Let's just double check though. On a calculator paper, always double check anything you do in your head. Avoid any silly mistakes. 130, yeah, so I would have made a silly mistake there. No, actually, I've made a mistake typing into my calculator, not in my calculation. So I should have done 34, not 24. There we go, 120 like I thought. Okay, so back to this then. So X is going to be equal to 23.8 times by sine of 34 divided by sine of 120. And then I would just type it in like that. So as a fraction, 23.8, I'm double checking my numbers as I type, times by sine of the angle, sine 34, divided by sine of 120. So we're looking at 15.36766 ... I've not rounded at any point, so this should be pretty exact. So to one decimal place, I'm looking at 15.4. Okay, question 14. Here are two squares at A and B. The length of sides of square B is 4 times then the length of sides of each of the square of A. The area of square B is 70 centimeters greater than the area of shape A. Find the area of shape B, giving your answer correct to 3 significant figures. Okay, so we're going to be using scale factors here. If I look at A and B and then discuss the length scale factor. So the length scale factor of A to B is 4 times greater than the length, so it's going to be 1 to 4. So the area scale factor is going to be, in effect, 1 to 16, because it's the length scale factor squared. What we're actually told is that the area of square B is 70 centimeters greater than the area of square A. So that's the difference. So there are 17 parts. This square B has actually got 15 more parts. So if I do 70 divided by 15, so 70 divided by 15 is going to give me 4.6 or 4 1/3. That's what each of those parts would be. So find the area of square B. I think I'm going to be timesing that by 16. So I've kind of messed up here. So the ratio isn't 70 centimeters. So I'm going to just set this up slightly differently. So the way I'm going to do it is I'm just going to call this length x to start with, and this would be 4x. It is a square, so the area of this one would be x squared. And then the area of this one would be 16x squared. So then if we talk about the difference, this one has, this one has 15x squared more. So that 15x squared is equal to 70. So 15x squared is going to be equal to 70. So what I've done is I've kind of misread. This isn't really a scale factor question. So it doesn't say it's 4 times greater. It says it's 4 centimeters greater, and I've treated it as 4 times greater, which is where I've got it into a mess. So if I go, it is 4 centimeters greater, and I read it as 4 times greater. If I called this length x, then this would have to be x plus 4. So the area of this one would be x squared, and the area of this one would be x plus 4 all squared. So, and the difference, the area of B minus the area of A is equal to 70. So in effect, the area of B would be x plus 4 squared minus x squared, and that's what's equal to 70. So if I multiply this bracket out, that will give me x squared plus 8x plus 16 minus x squared is equal to 70. They would cancel, so I'd just be left with 8x plus 16 is equal to 70. If I minus 70 from both sides, I'd get 8x is equal to 54. 70 minus 16 is 54, and then divide both sides by 8. So 6 3/4. That's the length of x. We were asked to work out the area of shape B though. So that's so the area of B is going to be equal to x plus 4 squared. So if I do, now I've got x, if I add 4 to that and then square my answer, that gives me 115.5625. So 3 significant figures, that's going to be 116 centimeters squared. Apologies for that misreading of the question to start with. Okay, question 15. So describe fully the single transformation that maps A onto B. So interesting, we've got an enlargement. We've got a negative enlargement. So we can see we've got the same shape, but this one is bigger. It's also in a different orientation, kind of a 180-degree spin, which implies we've got a negative enlargement. Easiest way to work out the point of enlargement is to join like points up. I should have done that with a ruler. Let's try and get that line a bit better. So if I join like points up, that tells us the center of rotation. Just get rid of that line and insert another one. So we can do it for all points if we wanted to or felt that we needed to. We can kind of see where that's heading though. We'll do it with the third though, just to make sure. Same line. Okay, so all of the lines cross at that point. We're describing A onto B. So A is kind of twice as big, but it's a negative enlargement. So it would be an enlarge. Is it twice as big? It's not twice as big. It's gone from 2 to 3, so it's 2/3 as big. It's 1.5 times as big. So if I describe the fully transformation, it's an enlargement. And my pen's gone. So it's an enlargement, scale factor, minus 3/2 or minus 1.5. About the point 1, 1. And let's just have a quick look at the mark scheme. So the mark scheme says for an enlargement scale factor, so it's 2 marks for enlargement scale factor of minus 1.5 and center 1, 1. And you can pick up 1 mark if you've spotted that it's an enlargement of minus 1.5 or the enlargement and the center of 1, 1. Okay, question 16. Here are the first 5 terms of a quadratic sequence. Find an expression for the nth term. Okay, so just going to give myself a bit more space to do this. These can be incredibly complicated, but we'll see how. So the first thing you do is look at the first differences. For it to be a quadratic sequence, there should be a constant pattern on the second difference. So the first difference is 11. The second difference there is 17. Third difference there is 23. And then we've got a common difference of 29. And then we've got a common difference of 6, 6, 6. So that means that we've got half of this n squared coefficient. So our pattern should have 3n squared in it. Then if we look at what those numbers would be, so 3n squared when n is 1, that would be 1 times 3, so that would be 3. When n is 2, that would be, and again, we can use our function part on our calculator if we want. So I'm doing 3 times by x squared, sorry, x cubed. And I just want to go 1, I don't need the second function, I just want to go 1 to, to be fair, 1 to 5 is fine. So I've got the numbers 3, then I've got 24, 81, and then 192. I then need to look at the difference. So the difference is this one take away this one. So we've got a difference of minus 7 there, minus 3 there. Sorry, not minus 3, difference of 3 there. We've got a difference of 81 minus 38. So we've got a difference of 43 there. And then for the next one, we've got a difference of 192 minus I feel like I've lost one. Minus 61. So I've made a mistake on my table. I'll just come back to that. I was trying to work out why my numbers are too big. I typed in 3n cubed, not 3n squared. So let's do that again. 3 times by shift x alpha x squared, not cubed. So that's better. So my value should have been 3, 12, 27, and then 48. So my difference is, so I'm going to do it the other way around. I'm going to do my sequence, take away this. So what I need to add to this. So we've got to add 7 there. There we would need to add 9. There we would need to add 11. And there we would need to add 13. So the difference is quite an easy one to spot. The difference is going up in 2's. So the difference is going to be 2n plus 5. So my total sequence is this term plus this term. So my nth term is going to be 3n squared plus 2n plus 5. Okay, question 17. Question 17. Write down the coordinates of the turning point of this. So the turning point is quite... so the turning point is when this value is at its minimum. So it's whatever value will make the x value there 0. So that's going to be minus 12. And when that is 0, y is equal to minus 7. So that's how you read your turning point straight off a version of... Okay, question 18. This diagram represents a solid cone. The cone has a base diameter of 30 centimeters and a slant height of 25. A circle has been drawn around the surface of the cone at a slant height of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. Work out the area of the curved surface of the cone that is not painted grey. So the area of the curved surface that is not painted grey. So I'm going to start by, realistically, the things that I need here is I need to work out this radius, which I'll call x for now, and I need to work out this slant height here, which I'll call y for now. And working out y is a bit easier than working out x, but we will hit that as we get to it. I'm just going to look at similar triangles to start with. So these would have to be similar triangles. So in effect, if I've got a base of 20 here, and I've got a slant height of 25. This y value is going to be 25 minus 20, so that's going to be 15. So obviously that would be 15 as well, and that would be 25 as well. And these are similar shapes. So 25 divided by 15, I really want this length here. So 25 divided by 15, I'm in the wrong mode. So 25 over 15 is going to give me 3/5. So in effect, what we've got is a scale factor of 3/5. So if I do 20 times by 3/5, sorry, 20 divided by 3/5. So 20 divided by, times by, I'm getting myself muddled up. 20 times by 3/5 gives me 12. So the base length of this would be 12, which means that x is going to be equal to 6 centimeters, and y is going to be equal to 15. And then we can kind of work it out from here. We want the full surface area minus the smaller surface area, so the area that is not painted, so area of not painted is going to be equal to pi RL minus, I'm going to call it pi RL again, I'll call that 1 and 1, 2 and 2. So I'm looking at pi times by 10 times by 25 minus pi times by 6 times by 15. So I don't really need a calculator for this, so that's going to be 250 minus 30 minus 90, lots of pi. So that's going to be 160 pi. So provided I've done that right, it asks us for the answer in terms of pi, so that's it, 160 pi. Okay, question 19. So a hot air balloon is descending. The height of the balloon n minutes after it starts to descend is h n meters. The height of the balloon n plus 1 minutes after the start of descent, h n plus 1 meters is given by, where k is a constant. The balloon starts to descend from a height of 12,000 meters at 9:15. At 9:16, the height of the balloon is 240. Calculate the height of the balloon at that point. So in effect, let's look at H0, or the first starting height is 1200. H1, that would be at, I'll put the times in as well, so that's 9:15. That would be, when h is 1, 9:16. We've now got a height of 10,040. If I go back to the formula, it states that n plus 1, so h1 should be equal to k times by ho, so 12,000 plus 20. So we can kind of rearrange to get k here. So if I minus 20 from both sides, 1020 is going to be equal to 1200 times by k. So k is going to be equal to 1020 divided by 12,000. So it's going to be 17 over 20. I'm going to leave it like that rather than go decimal. So we've got H0, we've got H1. And what I'm going to do now is I'm going to put H1 in, and I'm going to work out H2, which would be 917, and then H3, which would be the time I'm after, 918. So I'm going to use a kind of an iterative version of the formula then. So I've got this. I'm going to start from the beginning just to give myself confidence that I've got it right. So that's H0. I want to do 17/20 times by my previous answer plus 20. So that should give me H1 as my first value. It does. If I press equals again, it'll just do my next value, so 904. And then equals again, that gives me my height, 788.4. So I'm going to go with that, 788.4. Okay, question 20. Right, question 20. There are only red sweets and yellow sweets in a jar. There are n red sweets in the jar. There are 8 yellow sweets in the jar. Saeed is going to take at random a sweet from the bag and eat it. He says the probability that the sweet is red is 7/10. Show why the probability cannot be 7/10. Okay. So if I look at this as a kind of a fraction for now, ratio for now. So we've got n and yellow. Sorry, we've got red and yellow. Red and yellow, we've got n red sweets and 8 yellow sweets. And what they're actually saying is show why the probability of it being red. So that's in effect the fact that n over n plus 8 cannot be equal to 7/10. So if I kind of multiply this, if I say it is equal to start with and multiply it out, I would get 10n being equal to 7n plus 56. So 3n is equal to 56. So n is equal to 56. 56 divided by 3, which doesn't simplify at all, which is 18 2/3. And n would need to be a whole number for that to be true. N would need to be whole. Better word than whole number, n would need to be an integer. Second part, after Saeed takes the first sweet from the bag and eats it, he is going to take at random a second sweet from the bag. Given that the probability that both the sweets he takes will be red is 3/5, work out the number of red sweets in the bag. So in effect, after Saeed takes the first sweet from the bag and eats it, he's going to take a second sweet from the bag. Given that the probability that both sweets he takes will be red is 3/5. So we've already done part of that. So n over n plus 8. That's the probability of him taking one the first time. The second time, the probability of him taking a red sweet now would be n minus 1. And the number of sweets left in the bag would be n plus 7, because there'll be one less. And we're trying to show that that can be equal to 3/5. Looking for a shortcut for this, I can't really spot one. So what I'm going to do is cross multiply and tidy. So in effect, I'm going to have 3n times by n minus 1, and that's going to be equal, sorry, that's 5. and that's going to be equal to 3 times n plus 8 times by n plus 7. Right, and I need to multiply that out and then tidy it up. So I will multiply out the first bracket, that will give me 5n squared minus 5n. If I multiply out the second bracket, I'm going to leave the 3 for now though, that would give me n squared plus 15n plus 56. Right, so 5n squared minus 5n is equal to 3n squared plus 45n plus 168. Double check that though. Let's just check. 8 times by 7 times by 3, 168. Okay, so I'm now going to take everything over to the one side and hope that it factorizes. So if I take everything over to this side, it will keep my n squared positive, so that would be 2n squared minus 50n minus 168 is equal to 0. I'm going to halve everything because that's going to keep things a little bit simpler for me. So n squared minus 25n minus 84 is equal to 0. And then I'm going to assume that they factorize. That's my first method. Right, so n and n. I'm looking for two numbers that multiply to make 84 and that add to make 25. So 84 divided by 3 is 27 and 3. 28 and 3. 28 and 3, multiply, and then 28 minus 3, so I've got plus 28 and minus 3. Let's just double check that. I've got that the wrong way around. So if I multiply that out, that will give me n squared minus 28n plus 3n, so that would work. Meaning that n is either equal to minus 3 or 28. We would get rid of the negative value because we can't have a negative number of suites, so we would have 28 suites. Okay, I thought I was a bit tight on space. We've actually got our answer line here, but our answer is 28. Okay, graph of the curve y is equal to f of x is shown in the grid below. On the grid above, sketch the graph minus x. So that's going to be a reflection in the y-axis. So in effect, I need to make an attempt to reflect that in the y-axis. So I'm just looking at the key properties. So there we go. Just a clear attempt to reflect it in the y-axis. Find the equation of S. So we've got a negative quadratic. Let me just check which one I've got. So this is C. So we know the equation of this. It's transformed to give the graph S such that, and then all we've done is move it 3 in the y direction. So in effect, if this was a function of x, this would be a function of x minus 3. So as an equation, all we're really going to have to do is say that y is equal to 5 plus 2 lots of x minus 3 minus x minus 3 all squared. I'm just trying to look whether I need to tidy that up, because I could definitely tidy that up. Yeah, there's no need to tidy that up. That's absolutely fine. So I'd leave it like that, just because I'm showing the transformation. Right, last. Okay, final question, I believe. Yes. So circle C has centre in the origin. A tangent to the circle C passes through the point minus 20, 0, and 0, 2 work out the equation of C. So let's kind of discuss what we've got. We've got equation of a circle passing through the center. We've got a point at roughly minus 20, 0. I know, we're told 2 points that the circle passes through. That's very badly drawn. Minus 22, minus 20, 0. Okay, so the way I'm going to do this is I'm going to start by working out the gradient of the tangent. So the gradient of the tangent would have a gradient of change in y. So it's gone from 0 to 10, so it's got a change of 10. And in my x, my change in x has also gone up by 20. So it would have a gradient of a half. So the gradient of my radius would have, so I'm going to call that MR, would have a gradient of minus 2. So that leaves me with the gradient of the radius. The equation of the radius would be y is going to be equal to minus 2x plus c. And I know that it passes the point where they intersect. And I know that it crosses the y-axis at 0. Because so it must have an equation of y is equal to minus 2x. And I'm going to go a little bit further. So if I come back to the equation of my tangent, so that is going to be y is equal to a half x. And then the intercept on the y-axis we're given plus 10. And I can actually put these two equations equal to each other and work out the x value and the y value. Yeah, I'm going to do that. So, okay, so from here, I've got the equation of the tangent and I've got the equation of the radius. If I try and find the point where they intersect, in effect, I'm going to put them equal to each other. So I'm going to say that a half x plus 10 is going to be equal to minus 2x. If I rearrange that round, then that gives me 2.5x is equal to minus 10. So x is equal to minus 4. So that's the x coordinate there of the intersection. And the y coordinate of the intersection then is minus 2 lots of that, so would be 8. And then from there, so in effect, I've got the coordinate on the circle of minus 4, 8. And that must satisfy the equation x squared plus y squared equals r squared. So that I just need to do minus 4 squared plus 8 squared to find out what r squared would be. So 4 squared plus 8 squared gives us 80. So 80 is equal to r squared. And I would jump straight from that. I would say that x squared plus y squared equals 80 for my equation. Okay, and that brings us to the end of that paper. Next thing I will show you, this is the skills map for that paper. So 22 questions. If you struggled, for example, mostly on question 15, that's going to be transformation. That's where you're going to target some of your specific revision. This data is quite interesting, but I wouldn't overly worry about it at the moment. It talks about the mean score and the max score for each question, which kind of almost tells you how complicated students found the questions. and you can do the same thing for a breakdown for the average grade that people scored. So that's quite an interesting page if you want to look into a bit more detail of it. Finally, grade boundaries for that paper, that was paper 2H. So we're taking this from the November 2020 series. They were recommending 63 for a 9, 52 for an 8, 42 for a 7, 32 for a 6, 22 for the 5, and then 12 marks on that paper for a grade 4. Anyone that did get above 7 were also awarded a grade 3. I hope you found that useful. Thank you for your time. Questions or comments or feedback, feel free to type it into the video thread and I'll get back fairly quickly. And subscribe if you like.